In this video, we are going to be discussing circular arc length and how to evaluate and find it. So, an arc length is the distance along a circle's arc. So basically, it is going to be some type of proportion of the circumference, because if you remember, the circumference of a circle is the distance around the circle. Now, in geometry, we learned that the arc length is going to be the degree divided by 360 times the circumference, 2 pi r. Well, because we have already learned the conversion factor of pi in 180 degrees, we know that 2 pi is the conversion factor of 360 degrees. So what we're now going to learn is if you take the 2 pi and 360, it turns it into the radian, and we're going to multiply that radian times the radius. So the arc length formula is S, which is the arc length, and you're going to multiply that, that is going to be equal to the radius of the circle times the angle in radians, not degrees. We are only going to deal arc length in radians from now on. A circle has a radius of 6 and it has an angle of 2 pi over 3. So the arc length S is going to be r times theta. Well, we know r is 6 and we know theta is 2 pi over 3. So therefore, and I guess 6 meters. So S is going to be 6 times 2 pi over 3. So it is going to be either 4 pi meters, or if you want to know what that is as a decimal, it will be 12.57 meters. So basically what it's saying is if you have a circle, that's not a circle. Let's say you have a circle. That's supposed to be a circle. Obviously I cannot draw a circle. So let's say you have a circle and you say that the radius is 6 meters and you wanted to go to a terminal side of 2 pi over 3, which is about right there. That is roughly about 2 pi over 3. And you wanted to know if you're like, let's say you're a runner on a circular track and you are running and you want to know what is the distance as you're running to this point. What is that distance? And that distance is 12.57 meters long. So let's do it again. We have S equals R times theta. We know the radius is 4 inches, but here's the problem. Theta is not in radians. So what we're going to have to do is we're going to have to convert. So I know that my conversion factor is pi over 180. So 240 goes down there. We need that in radians. So 240 pi equals 180x. So 240 pi divided by 180 is going to be my radians, which is going to be 4/3, 4 pi over 3. So now we can actually solve. So the radius is 4, and we're going to multiply that by the radians, which is 4/3. So our answer is going to be 16/3 pi inches, or 16.755 inches in distance. Now we want to know the angle that intercepts the arc. And so now we actually have the radius and we have the arc length. So in S equals R times theta, we actually know S this time and we know R this time, and we're trying to find theta. So 5 equals 15 times theta. So divide and you get 1/3. Now be careful, this is not 1/3 pi. This is just the number 1/3. So what you would say, this is 1/3 radians would be your actual standard answer. Real world connection. Find the distance between Dallas, Texas and Omaha, Nebraska. We are assuming at this point that they are due north of each other. And we know that the Earth, well, we don't know. Let's just assume at this point that the Earth is a sphere, which we know it's not, but let's just assume. And the radius is 4,000 miles, which is not, but it's pretty close. And the longitude. So here's what's actually happening. And this is actually what degrees and longitude and latitude all have in common. Like the 30-degree parallel, which is roughly about like maybe, I think New Orleans is roughly at the 30-degree parallel. What it's saying is that if you take the equator and from the core center of the Earth, which technically we don't know where it is, but we're just assuming, and you were to draw a 30-degree arc, like let's say you had a giant protractor and you were doing a 30-degree arc from the equator, you would create a circular line all the way around, which is be the 30-degree parallel. So Dallas is at 32 degrees, 47 minutes, and 39 degrees seconds. So let's say Dallas is probably like, if that's 30 degrees, about like right here. That is Dallas. We need, let's do white. Ooh, there's Dallas. And Omaha, Nebraska is about right there. What we're wanting to know is we actually want to know the distance. Now, it's not a straight shot because the Earth is curved. That is why this becomes a little different, because when you take the curvature of the Earth into account, it is going to be a different distance than if you were to just straight draw a string. So, first thing we have to do is we have to go back and remember how to convert degrees, minutes, second into a decimal. So if you remember how to do that in the calculator, you're going to go 32 degrees, and then you are going to do, if you remember where the degree is, if you hit second apps, that's basically taking you into the angle function. And so you would hit 32, second apps is degree. And then 47, go back into second apps, down to minute, and then 39. And this is where you have to do the alpha. But to get to the second, you're going to hit alpha and then the plus sign. And that will get you the 2 tick marks. And if you do that, then Dallas would become 32.794. Do the same thing with Nebraska. And you would get 41.264. So these are the exact degrees. Dallas is at 32.794 degrees. Omaha is at 41.264 degrees. So basically what we're doing is if we are drawing, we need to find, well, first we know the radius is 4,000. We need to find this angle. Well, first thing we need to do is we need to find it as a degree. So if you subtract these two numbers, you will get 8.4698 roughly degree. But we need this in radians. So I'm going to take my conversion factor, and we are going to just cross multiply. And I'm going to go ahead and multiply. Since I already have decimals, I'm going to go ahead and do that. So 8.46, multiply that by pi, then divide that by 180. And I'll get 0.148 radians. Now, I know the radius and now I know the radians, so I can actually find the distance. So 4,000 times 0.148. That means that the distance from Omaha to Dallas is 591.3 miles. Because you have to take into consideration that there is a slight arch because of the surface of the Earth.